Pluto is a faraway, elusive, and less conspicuous planet that was once considered part of our solar system. However, recent groundbreaking statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into public discussion. They have proposed that this icy planet might be heading toward a potential collision course with Neptune. But how can such a scenario be possible, and what would the consequences be of such a monumental event? Are we witnessing an unusual, unpredictable phenomenon, or is there 34 seconds something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, which was once classified as a planet but later redefined as a dwarf planet, continues to be a subject of fascination and study within the vast universe. Recent speculations from leading experts have suggested that Pluto's orbit is alarmingly close to Neptune's, prompting astrophysicists Neil deGrasse Tyson and Michio Kaku to warn of the possibility of a catastrophic encounter between these two 1 minute and 5 seconds celestial bodies, which could pose a significant risk to Earth. But how could such a collision even occur? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete one full orbit, and since its discovery in 1930, Pluto hasn't even finished a single full revolution. However, the intrigue doesn't end there. Pluto's orbit is characterized by its distinctly elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's orbit even 1 minute and 40 seconds more unusual is its tilt. Its orbit is inclined at an angle of 17 degrees to the plane of the solar system. This gives Pluto's path a far more erratic trajectory compared to the more orderly orbits of the other planets, adding complexity to its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is the way it intersects with Neptune's. For roughly 20 years during each orbit, Pluto actually travels closer to the Sun than Neptune does, defying the conventional expectation of their relative positions in the solar system. 2 minutes and 13 seconds. This raises the obvious question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational forces exerted by other planets. After Pluto's discovery, astronomers quickly set out to understand its strange orbital behavior. Unlike the other planets, whose orbits are relatively close to the solar plane, Pluto's orbit stands out because of its steep inclination and highly irregular shape. The puzzle deepened when it became clear that Pluto's orbit intersects Neptune's. Despite this, Pluto's orbit, 2 minutes and 45 seconds, remains stable, demonstrating the intricate dynamics of celestial mechanics, or the so-called three-body problem in space. Understanding how three objects, like Pluto, Neptune, and the Sun, interact gravitationally is key to this scenario. It's like trying to predict where these objects will be based on where they started and how they influence one another. The stability of all planets' orbits is ensured by the concept of non-concurrent libration. In the case of Pluto and Neptune, this means that whenever Pluto crosses Neptune's 3 minutes and 17 seconds orbit, the two bodies are always positioned at least 90 degrees apart. This spatial separation prevents a collision between them. Another contributing factor is orbital precession, which refers to the slow vertical movement of a planet's orbit. For Pluto, this means that when it comes closest to Neptune, or any giant planet, it is positioned well above their orbital plane, providing another layer of defense against potential collisions. An additional factor at play is the VSK wobbling, a concept named after 3 minutes and 48 seconds researchers, Vakadov, Sidorenko, and Kolshevnikov, who studied how celestial bodies interact with one another's gravitational pull. This wobbling effect explains why Pluto's orbit, though seemingly chaotic, remains stable over long periods. The gravitational tugging between Pluto, Neptune, and the Sun influences Pluto's orbit, ensuring it remains relatively smooth despite its irregular shape. The VSK wobbling shows that even in the most unpredictable environments, there are underlying patterns and forces that maintain stability. This three-body, 4 minutes and 21 seconds problem is crucial to understanding the nature of Pluto's orbit, its relationship with Neptune, and the behavior of distant objects in our solar system. Numerical simulations conducted in the late 1980s revealed that Pluto's orbit, despite the stabilizing forces at play, is actually quite erratic. Small deviations in its initial conditions could lead to significant differences in its path over centuries. Nevertheless, these simulations also showed that Pluto's orbit maintains stability over incredibly long timescales, such as 4 minutes and 54 seconds, millions or even billions of years. To fully grasp the dynamics between Pluto and Neptune, it is important to consider the gravitational influence of the giant outer planets, like Neptune, Jupiter, and Saturn. Neptune's influence is significant, as it governs Pluto's orbit in a special resonance. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This gravitational resonance helps to keep Pluto's orbit stable. But Neptune is not the only player in this complex equation. Jupiter's massive gravity also plays a 5 minutes and 28 seconds key role in stabilizing Pluto's path, while Saturn further contributes to this dynamic. These forces, working together, ensure that Pluto remains on a steady course for potentially millions of years, keeping it out of harm's way from Neptune's influence. Without these stabilizing forces, the solar system would be much more chaotic, with planets potentially colliding or being ejected from their orbits, triggering catastrophic consequences across the solar system. The possibility of Pluto colliding with Neptune in the future. 5 minutes and 58 seconds highlights the complexity of celestial mechanics and the importance of studying the stability of orbits. By understanding these intricate dynamics, we gain a better understanding of how the solar system works, the role of gravitational forces, and the behavior of distant objects. Even though Pluto's orbit may appear chaotic at first glance, it is a testament to the delicate balance of forces that keep it in place. Exploring space often leads to surprising discoveries, and Pluto's irregular orbit serves as a prime example of the 6 minutes and 29 seconds mysteries of the cosmos. The rest of the text follows the same pattern of grammatical corrections and punctuation improvements. As scientists continue to refine their models and simulations, the question remains: could an unforeseen gravitational disturbance disrupt Pluto's stable orbit and lead to an eventual collision with Neptune? While the likelihood of such an event remains low, cosmic uncertainties persist. The gravitational influence of an unknown celestial body, perhaps a rogue planet or a passing star, could introduce unpredictable variables into Pluto's trajectory. Even the gradual changes in the Sun's mass, as it slowly loses material through solar wind, might subtly shift the orbits of planets over millions of years. 15 minutes and 28 seconds. But what would happen if Pluto and Neptune did collide? Would it be a cataclysmic event, altering the structure of the outer solar system, or would it simply create a new set of celestial bodies, born from the remnants of 2 worlds? A direct collision between Pluto and Neptune would be unlike anything witnessed in recorded human history. Unlike smaller asteroid impacts, this event would involve 2 large celestial bodies, one a frozen dwarf planet, the other a massive gas giant. The impact could generate an immense burst of energy, sending fragments of Pluto scattering across the solar system. Some of these fragments could be captured by Neptune's gravity, forming new moons or a dense ring system around the planet. Others might be ejected into space, potentially crossing paths with Earth or other planets over the course of millennia. 16 minutes and 2 seconds, however, an actual impact remains highly improbable due to the orbital resonance that keeps Pluto and Neptune in a stable gravitational dance. Even if Pluto's orbit were slightly perturbed, the interactions between it and the outer planets, particularly Neptune, Jupiter, and Saturn, would likely prevent a direct collision. This balance in celestial mechanics highlights the incredible precision of our solar system's architecture. While chaos theory suggests that even small changes in initial conditions can lead to wildly different outcomes, the gravitational interplay among planets helps maintain long-term stability. 16 minutes and 38 seconds. Nevertheless, the search for potential disruptions continues. Astronomers remain vigilant, scanning the outer reaches of our solar system for unknown objects that could introduce new variables into this delicate equation. The possibility of a yet undiscovered Planet 9 influencing Pluto's orbit remains an intriguing hypothesis, one that could reshape our understanding of planetary dynamics. As we probe deeper into the mysteries of our cosmic neighborhood, Pluto's story serves as a reminder of the dynamic, ever-evolving nature of the universe. What appears stable today may shift tomorrow, and the forces that govern celestial bodies remain both awe-inspiring and unpredictable. 17 minutes and 12 seconds. In the end, Pluto and Neptune's gravitational relationship is not just a question of potential collisions, it is a testament to the vast complexity of the cosmos. Whether they continue their orbital ballet undisturbed for billions of years or experience some unforeseen disturbance, their celestial interaction will remain a subject of fascination for generations to come. For now, we watch, we calculate, and we learn, knowing that the universe still holds secrets far beyond our current understanding. As telescopes scan the night sky and simulations run on supercomputers, the mystery of Pluto and Neptune's intricate dance continues to captivate astronomers. Yet, beyond the realm of predictable orbital mechanics, a deeper, more speculative question lingers. Could an external force disrupt this delicate balance and send Pluto hurtling toward its gas giant neighbor? 18 minutes and 12 seconds enter the possibility of an interstellar intruder. Throughout the history of our solar system, rogue celestial objects, whether comets, asteroids, or even planets, have passed through, tugging at the orbits of known bodies in ways that are still being unraveled. If a massive interstellar object were to pass near Pluto, its gravity could exert just enough force to alter Pluto's trajectory, potentially pushing it out of its well-maintained resonance with Neptune. Even more unsettling is the notion of a passing star. Astronomers have long speculated that in the distant future, another star could venture close enough to disrupt the Oort cloud, the vast sphere of icy bodies surrounding our solar system, sending debris inward toward the Sun and its planets. If such an event occurred, Pluto could be nudged onto a collision course with Neptune or even ejected from the solar system entirely. 18 minutes and 56 seconds, but the universe is full of surprises, and not all of them spell disaster. What if, instead of a catastrophic impact, an altered orbit led to an entirely new celestial phenomenon? Pluto could become a captured moon of Neptune, much like Triton, Neptune's largest moon, which is believed to be a former Kuiper belt object that was drawn into the planet's orbit billions of years ago. If this were to happen, Pluto's surface would be subject to immense tidal forces, heating its icy crust and possibly igniting subsurface activity similar to the volcanic plumes observed on Jupiter's moon Io. 19 minutes and 34 seconds for now, however, Pluto remains locked in its peculiar, stable path, an anomaly among planetary bodies, yet a testament to the unseen forces that govern the solar system. Every observation, every new piece of data adds another layer to this cosmic puzzle, but one fact remains unchanged. The universe is a place of constant motion, where even the most stable orbits may one day shift in ways we cannot yet predict. 20 minutes as astronomers refine their models and explore new frontiers in celestial mechanics, one question remains. If Pluto and Neptune's dance is disrupted, what will be the catalyst? A rogue planet? A passing star? Or some yet undiscovered force lurking in the vast expanse of space? For now, the answer remains hidden among the stars, waiting to be uncovered.